Today we're going to be talking about section 8.3 in Algebra, multiplying powers of exponents. Our main concept talks about dealing with powers when we're having the same base but different exponents. To analyze this, we look first and say, what does it mean to have 3 to the 5th? Well, that's 3 times itself 5 times. So that's represented by these first 5 numbers. What does 3 squared mean? Well, that means 3 times 2 numbers. Well, if I look at this as a complete unit, how many numbers do I have multiplied together? Well, that's 7. So 3 to the 5th times 3 squared is 3 to the 7th. Notice the bases, since they're the same, we can add the exponents. So a general rule would look something like this. X to the a times x to the b equals x to the a plus b, as a good general rule. So let's rewrite these expressions below using each base only once. Our first one, we have 7 to the negative 13 and 7 to the 5th. Since both bases are the same, what can we do? We can add the exponents. So down here you see I've added negative 13 plus 5 is negative 8. So what's my answer? 7 to the negative 8th. Did you remember that we can't leave our powers of exponents as negative? Did you remember that this then should be written as 1 over 7 to the positive 8th? Please don't try to work this out, but if you wanted to, you could try to guess what that is in terms of 7 to the 8th. Is it greater than 1,000? Is it greater than 10,000? Well, actually, it's 5 million. If we were writing that number out, it would be 1 over 5,764,801. Because this is such a large number, it's okay to leave your answer in this case as 1 over 7 to the 8th. Now let's look at our second one on this page. We have 4 cubed, 4 squared, 4 to the negative 8th, and 4 to the 5th. All the same base. So let's add our exponents. 3 and 2 makes 5. 5 and negative 8 makes negative 3. Negative 3 and 5 makes 2. Since this number is a fairly small number, we can easily work this out and get 16. As we continue to look at this, let's look at our second page. Example 2 talks about powers of exponents once again, but with variables. Do we have the same base? We sure do. So let's add our exponents. Negative 3 plus 2 plus 8. Negative 3 plus 2 is negative 1, plus 8 is positive 7. So our answer is x to the 7th. In part B, we have numbers in front and exponents in back. So our goal here will be to do some grouping. Let's group first the numbers. 2 times 5 times 2, and then let's group our x's. X squared, and x to the negative 11. As we work through this, we're going to have to do our 2 different problems together. 2 times 5 times 2, well, that's 20. X squared, and x to the negative 11 is x to the negative 7. As we learned from previous lessons, one of the 2 of these is going to have a change. That's this negative exponent. But the 20 doesn't have a negative exponent, so that's going to stay on the top, and the x to the 7th will go to the bottom as our final simplified answer. Our final problem of this lesson has 2 different variables as well. Let's group them together first. All the c's, c to the 4th, c to the 3rd, and c to the 4th in our first group, and then d to the negative 4 and d to the negative 2 in our second group. How many c's do we have total? Well, that's 11. And then we also have negative 6 d's. As we try to write this as our solution, since the d has a negative exponent but the c does not, we're going to move that d to the bottom and leave the c on top. So our answer will be c to the 11th over d to the 6th. Let's move over here to the right side and do a little of a challenge problem as our final problem, just to make sure that we have good comprehension of the material. Let's pick some variables and some numbers. I'm going to start and I'm going to say 3a squared b to the 4th. My second one is going to be 2a to the 5th b to the negative 10. And then my third one will be 4ac to the 0. Well, let's group our numbers at the front first. 3 times 2 times 4. Now let's group our a's. A squared, a to the 5th, and a single a. We haven't seen a single a before. Now our b's, b to the 4th, b to the negative 10th. And then lastly, we have a c to the 0 tacked on at the very end. Well, let's evaluate this now. 3 times 2 is 6. 6 times 4 is 24. We have a squared, a to the 5th, and an a. And my question is, what do we do with this a by itself? Well, that actually has an exponent of a 1. So if we add those all up together, we get a to the 8th. 4 minus 10 for our b's is negative 6. Do you remember that anything to the 0 is 1? So really the c to the 0 is 1, and we don't need to write it back there. So is this our answer, 24 a to the 8th, b to the negative 6th? Well, the fact that I have a negative exponent should tell you I don't. That b to the 6th goes to the bottom, leaving the 24 a to the 8th on the top. Hopefully this has been a good explanation of negative exponents for you.